Welcome to another podcast. In this episode, we're going to be taking a look at basically how to perform a solution for compound interest problems where we're trying to find the present value instead of the future value. So there's going to be a little bit of algebra involved here. Nothing too terrible, though. So I want to start out by sort of reading through the problem here. This is typical of a present value problem. A new child's being born. The parents want to establish an account to pay for college when the child turns 18. So they're trying to figure out how much money should they deposit on the day of the birth so that in 18 years the money would grow to be $30,000 that would allow them to help cover tuition for a little bit. And I want to assume that throughout this process the investment earns a rate of return of 8% compounded monthly. So one of the things I will often tell students to do when they're faced with word problems such as this is to list all of the relevant variables. And if you think about our compound interest formula, remember that it looks like this. And we should know by this point what each of these variables represents. And so I'll usually just ask students to create a list somewhere on their paper, or I'll provide them with a listing of the variables. And we'll need to come up with the value of each variable and figure out which one we need to solve for. In this case, the future value of the account is $30,000. That's made plain by the fact that that's how much we want the account to grow into 18 years later. And so the present value or principal amount of the account is the amount that we want to solve for in this problem. The interest rate is 8%, but remember we're going to enter this as a decimal into the formula, so it's 0.08. And then N is the number of compounding periods per year, which in this case it says monthly, so that implies that N is 12. And the time frame for this is over 18 years. So now that we have everything together, let's go ahead and plug it into the formula. The formula is going to become 30,000 equals P times 1 plus 0.08 divided by 12 raised to the 12 times 18. So if I wanted to solve for P, what I will typically recommend students to do is do all of the work at once in their calculator. So take 30,000 and divide by 1 plus 0.08 12 times 18. So just treat this as if it were a number, call it B, and then you're going to divide by B because it essentially is B. It's the same sort of growth rate idea that we had in the exponential models video. So you're going to divide by that amount, and that's going to be equal to the present value or principal amount P. It's at this point that we need a calculator to become involved. And so if you have your Math Studio calculator, if you have a TI or whatever you're using at home, we can just do 30,000 divided by 1 plus. Now you got to be careful here. I want to make sure that the calculator knows that you have one fraction there, as well as you have this separate exponent. And then I also need to make sure that the denominator as one big thing is wrapped up in parentheses as well. So this would be the correct way to enter it. Notice that you get the value $7,141.88. So the present value here is $7,141.88. Now in and of itself that's pretty easy. But I'd like to also contrast this with another method that we're going to be talking about in class, and that's using a command in our calculator. In the TI calculators, it's called the TVM solver. In our calculators, it's called the finance command. So if I tried to solve this problem using the finance command, then the finance command takes a couple of values. It takes first the principal amount, then the future value, then the payment size, which we haven't talked about problems involving payments yet, but we'll get there. Then it takes the interest rate per period. So this is a new variable for us, lowercase I. And then it takes what's n times t, which is the total number of compounding periods. So n times t is the total number of compounding periods. It matches the exponent here. So the total number of compounding periods is 12 periods a year for 18 years. So when we go and calculate the finance command answer for this problem, n times t is going to be 12 times 18. All right, so I guess we'll move from right to left. The next up is lowercase I, which is the interest rate per period, meaning it's 8% per month, which is a total of 0.66 repeating percent. This is the monthly rate. So if it's compounded monthly, you want the monthly rate. If it's compounded quarterly, you want the quarterly rate. It's 8% a year, but 0.66 of that, or 2/3 of a percent of that, is per month. So the easiest way to do that is just remember that it's the same thing as what's here in the formula. That's the interest rate per period. But remember to enter it as a percentage in this command. So R is equal to 0.08, but in this command you enter it as 8%. So you'll put in 8 divided by 12 for this problem. It's the percent over n. So it's R over n, where R is as a percentage. This is different than entering it in the formula, because in the formulas we use this as a decimal, but in the finance command we use this as a percentage. So this is the percentage per year divided by the number of compounding periods per year, which is 12. Next up is the payment. We're not making any payments. It's a one-time deposit, so the payment size is 0. We've already said the future value is $30,000. Please understand that I didn't put any commas in that number, so avoid commas because commas separate the different values here. And then finally, the principal amount is the amount that we want to solve for. So I usually just put an X there in the command, and you'll see us look at the command here in a second. So the way that this works is I'm going to go to my catalog, go down or search for the F's, find the finance command. If you forget what to put in, it's got a listing there of each piece to put in. But the finance command, solving for present value, future value of 30,000, payments of size 0, there's no payments in this problem, an interest rate of 8% per year, divided up into 12 months for 12 months a year times 18 years. So you can see that we end up with the exact same answer here as doing the problem by hand. The finance command is going to be a very fast way of handling these problems, but you shouldn't lose sight of the parts of the formula, the compound interest formula, that get directly applied, like the 8 over 12 here versus the 0.08 over 12 here, they get directly applied to this new command. The 1218 here versus the 1218 here. All right, so either way, the result of this process is we're going to end up needing to deposit $7,144.88 in order for that money to grow to give or to yield the $30,000 that they need in 18 years. So this is just one example designed to sort of compare and contrast plugging values into the formula versus plugging values into the calculator using the finance command. This works similarly. If you have a different calculator, it'll be a similar set of steps in order to calculate the values for those problems as well. All right, thank you for watching.